Meanwhile, in Peninsular Malaysia, the flood there expected to worsen over the next 24 hours. Tropical storm Senia is forecast to move eastward across the region.
Hey, look at him. I think he seems such in a big trouble. Why don't we approach him? Let's go.
Sorry, sir. What's your name? Oh, no, you can say.
My name is Adif. My name is Adif.
My name is Zed.
My name is Mike.
Can I have a seat, please?
Yes, of course. Thank you. That's it, please. Why you look very troubled? Yeah. What is the matter?
The problem is, my house was swept away due to severe flooding.
Sorry.
Don't worry, we are here to help you.
I think I have an idea to solve your problem.
Floating houses are structure designed to rest on water, providing solution for flood-prone areas and water-based communities. Unlike traditional buildings on solid ground, a floating house relies on a buoyant platform to support its weight, which introduce unique structural techniques. The platform must not only carry the load of the house itself, but also accommodate dynamic loads such as occupants moving, furniture placement, and environmental force like wave or wind.
From a structural engineering perspective, the critical section of the platform such as corners, edges, and main supporting beams experience higher moments and shear forces than the average at the center of gravity. This highlights the importance of careful structural analysis, as focusing only on the average load may overlook points of maximum stresses that could lead to tilting or localized failure.
In real-life application, this principle ensures that floating houses remain stable and safe. Engineers design platforms that can resist bending or uneven loading while maintaining overall buoyancy. Modern floating house designs often incorporate reinforced composite material and modular platforms, with every critical section analyzed to prevent structural issues.
This project applies these theoretical concepts to the design of a floating house platform, demonstrating how proper structural analysis ensures stability, safety, and practicality in real-life water-based living environments. Adif, why don't we jump to the model right now?
I think so.
Let's go.
Okay. First of all, we are using a sustainable item such as a box to make the body of the house and also the roof. For the base, we are using a hardboard which make the house keep in its place while floating. We also put two loads in front of the house and also at the back of the house, which both of them are 100 grams respectively, to test the buoyancy of the model of the house.
Now I will explain about this main structure component. The main structure component is a sponge foam, which is replace plastic bottle used in the reference design. What we know, all people, if we do the something of floating, they use the bottle to give the object float. But we redesign this project to use sponge foam. This component make the house floating above the water. This sponge foam provide a larger surface contact area with water, so resulting in improved buoyancy and stability. Okay, come. We will explain about this box. Okay, this box just make from the reality in one place have a float. Okay. From the project, we use 4 sticks. This 1, 2, 3, 4. Okay. This stick we use to hold this house, from to avoid being swept away from the flood lah. So this stick just replace the structure to hold stronger the house. Okay, now I and my friends went to explain about theoretical explanation. First is buoyancy. Buoyancy is a tendency of fluid to exert supporting force on a body placed in fluid. The second is stability. Stability is the ability of a body to return to its original position after being tilted about a horizontal axis. Okay, so we can see at the slide have a four condition with the different object in a container. The condition one, the condition first and two is positive buoyancy. The third is negative buoyancy, and the last one is naturally buoyancy. So in my project is positive, same like condition 1 and 2, because the value of buoyancy force is more than the object weight, and if the weight is more than buoyancy force, it's possible to fully submerge. And if an object does not sink the bottom, but also does not float on the surface, and instead stay suspended in the water, it means the object has neutral buoyancy.
Okay, now I want to continue explain about theoretical. From the diagram given, on the left, the floating house is stable and upright, with the center of gravity, center of buoyancy, and metacenter all lined up vertically. This means the forces balance perfectly, so no tilting moment is created, indicating a stable condition. On the right, the house tilts due to external forces like wave or wind. When it tilts, the center of buoyancy moves sideways, while the center of gravity stays in place. This creates a distance between them, producing a moment that tries to rotate the house further. This stated position represents an unstable condition because the moment increases the tendency to tip over. Because of this, the overall effect at the metacenter is greater than at the center of gravity, which helps explain the floating house stability behavior. For the next part, I want to explain why YMC greater than YCG. The reason why YMC greater than YCG can be explained using key hydrostatic principle. First, the buoyant force does not act at the center of gravity, CG. It acts at the center of buoyancy, CB. This separation between CG and CB creates a moment that affects the floating house stability. Second, when a load is placed above the house, it increases the total weight and raises the center of gravity, which in turn increases the overturning moment. Finally, at the critical condition, YCG only represents the weight acting at the center of gravity, while YMC includes both the effect of buoyancy and the additional moment caused by the weight. This combined effect also accounts for the restoring or overturning tendencies of the floating house. Therefore, the total effect at the metacenter is greater than that at the center of gravity, which is why YMC greater than YCG. Wait. How did I end up here? Ching. I think we have found the solution for the problem.
Don't worry, Hassan. I promise that we will build your house as soon as possible as the best floating house in the world.
Don't worry.